Hello, my name is Robert Smith and I'm with New River Community College's Academic Assistants, and today we are discussing net ionic equations. So we're given the task of writing the net ionic equation for the chemical equation given above. So let's get started. The first thing you're going to want to do with an ionic equation is anytime you see something as either aqueous or specifically aqueous, you'll want to split it up into its respective ions or complex ions. Anything that's solid or liquid, you'll want to leave alone as its own creature. It does not split off into its respective ions. So when we rewrite this, we break up the lead from the nitrate, the potassium from the iodine, all on the reactant side, and then on the product side we'll split off the potassium from the nitrate. So we can rewrite this as Pb, which is lead, and it has a +2 charge, or 2 plus, as your book describes it. And it would be aqueous. We want to note the state. And then there would be 2 nitrate ions, which has a -1 charge, and it's aqueous. 2 potassium ions, and they have a +1 charge, aqueous. 2 iodine ions, which have a -1 charge. Again, we're getting the charges from its position on the periodic table. The nitrate is a complex ion, and it has a -1 charge. And then so that's our reactants. Then we have our products, which again, the solid stays the same, PbI2, S for solid, plus 2 potassiums, aqueous, and 2 nitrates. Also aqueous. And we get that from the 2 coefficient in front of the potassium nitrate compound. So when you're looking at this, you'll see some common species on both sides. And those are called spectator ions, and they cancel each other out. So your 2 NO3s, your 2 nitrates, cancels with the 2 nitrates on its opposite side. The 2 potassiums in the reactants cancel with the 2 potassiums in the products. So once the spectators have dropped out, we can then rewrite the equation that is the net ionic equation, which would be Pb plus 2I yields PbI2, or lead iodide. And I'll have you note that the charges do cancel out on this. Lead has a +2 charge, or 2 plus charge, and iodine has a -1 charge, but there are 2 iodines. So it's 2 positives cancels with 2 negatives, and that's why our lead iodide does not have a charge attached to it. And that's our net ionic equation.